Now we have fractional exponents. If you have the nth root of some value to the m power, that's the same as, this is the same as the nth root of x to the m power. And that both of these are the same as x to the m over n. Why would we use these different forms? Well, let's say I have the fourth root of 16 to the fifth power. Well, I don't really want to calculate 16 times 16 times 16 times 16 times 16 without a calculator and then take the fourth root. I can turn it into the fourth root of 16 to the fifth power. Well, this is a lot easier because the fourth root of 16 is 2. 2 to the fifth power equals 32. Now that was easy. Another way we can look at it is this is the same as 16 to the 5/4 power, which is equal to 16 to the 1 power times 16 to the 1/4 power. Because 5/4 is the same as 1 and 1/4. And remember, we add exponents. This is equal to 16 times the fourth root of 16, which equals 16 times 2, which equals 32. Notice it's going to be the same. If I want to do the problem that is in front of us, this is D. Remember, the numerator goes with the variable and the index is the denominator. Now we have 64 to the 1/3 power. Well, 64 is equal to 2 times 32, 2 times 16, 4 times 4, 2 times 2, and 2 times 2. I have 6 2's. I have 2 to the 6th power to the 1/3 power. And if you remember your exponent rules, base to the power to a power equals multiplication. This is equal to the 6/3, which is equal to 2 squared, which is equal to 4. I have 81, 9 times 9. These are both 3 times 3. I have 4 3's. I have the fourth root of 3 to the 4th power, which is equal to 3 to the 4 over 4, which is equal to 3. Actually, fractional exponents are really helpful sometimes. It makes it a little easier to see why things are happening. We can take the odd root of a negative number, negative 125, if you factor it, is going to be equal to negative 5 times negative 5 times negative 5. This is negative 5 to the 3rd power to the 1/3 power, which is equal to negative 5 to the 3/3 power, which is equal to negative 5. Now, this one is very tricky. I don't know if you guys remember, but a while back, I talked about exponent rules. And exponents only act on what they're next to. This is the same as negative the fourth root of 81. The negative is on the outside because the exponent is only dealing with the 81. If this was in parentheses, if I had this, that is not a real number. That's the even root of a negative number is not a real number. But this is equal to -3. Now we have 81 to the 5/4 power. Well, that's equal to 81 to the 1 1/4 power. How do I know that? I just divide 5 by 4. I get 1 1/4. The remainder over the divisor. And 1 1/4 is the same as 1 plus 1/4. This is going to equal 81 to the 1 power times the fourth root of 81, which is equal to 81 times, we already know that the fourth root of 81 is 3. This equals 243. I have 27 to the -5/3. If you remember, when you have a negative exponent, it doesn't make anything negative. It just flips the position. Since this is 27 is in the numerator, it goes into the denominator, and this becomes positive. 5 divided by 3 is equal to 1 2/3. This is equal to 1/27 to the 1 times 27 to the 2/3 power. This is equal to 1/27. Now, how do I find to the 2/3 power? Well, I factor 27, and I know that that is going to be 3 to the 3rd power to the 2/3 power, which is equal to 1/27 times 3 to the 3 times 2/3 power. Those cancel. I get 1/27 times 3 squared, which is 9, which is equal to 1/24, 1/243. I have 1/243 to the -2/5 power. This is equal to 243 to the +2/5 power. What is 243? 243, factor, I know I can divide by 3. I get 81, divide by 9 and 9, 3 and 3, 3 and 3. This is equal to 3 to the 5th power to the 2/5 power, which is equal to 3 to the 5 times 2/5, which is equal to the 5 and the 5 cancel, 3 squared, which is equal to 9.